KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name's Pam Halstead and I taught science at Fortuna High School.
My name is Amy Taylor and I teach 7th and 8th grade math at Sunnybrae Middle School in Arcata.
Welcome to the show.
Yay.
We're so happy that you guys have tuned in.
Happy March.
Yes, happy March. Oh my gosh, the first day of March.
I know.
Amy, the spring is coming.
It is.
And the spring forward is coming, but
in a couple weeks, and
yes.
Pi Day and St. Patrick's Day and all these fun things
It's very
in March.
exciting. Very exciting. So we're so happy that you're here, and it's our math day today.
Yes, and we're going to do solving systems of linear equations, which is huge in 8th grade math, but also an integrated one, or what you'd call algebra one, those kind of like the 8th, 9th, 10th grade math kind of thing. And so I thought my students are having a test on it this week, all my 8th graders, and so I thought this was an appropriate thing to share, and it would help other people as well.
Very cool.
So we're going to do some graphing. So there's different ways. There's graphing. It was one way. You take two lines and they cross, and then you find their point of intersection. And that's graphically solving for it. Sometimes if you can't tell where they cross, it's like a fraction or decimal, you're not sure, they're not on those lattice corner points. Algebraically is always a good way, and you can get like precise. And so we'll have two ways, ones where we substitute one into the other, and ones where we take it and we eliminate a variable and find it. So I'm just going to cover almost like my whole topic in 3 problems, and that's how we'll do that. So but then it'll give you kind of a variety of how to do that. Okay.
All right.
So we're going to do one real world problem to start, because that's always nice to do.
Yes.
So if you want to go read it and we'll work together.
Okay. I would love to. It's about a town, everyone. Town 1. Town 1's temperature was going down an average of 1 degree Fahrenheit per day and started at 4 degrees Fahrenheit.
Okay.
All right.
And then I guess we can write the equation for that. We'll just do it one at a time.
Okay.
So basically the gist, I'm just going to write, so we have one thing that's repeating, and there's something called, I'll actually put it up here, y equals mx plus b, and that is called slope, y-intercept form. And we do that so that we can graph it, because that's an easy way to start with y-intercept and slope, where m is our slope and b is our y-intercept, where it crosses the y-axis. Okay. And with slope, it's like a rate. We're going to go dependent over independent, or rise over run. Okay. And that's just the background I realized I should do for graphing, and that's what we'll be doing the whole time.
Okay.
So can you think of what the slope would be here, or the y-intercept? Okay, go ahead.
Yeah, so would it be 1 degree Fahrenheit?
Yes, and it's going up or down?
It is going down.
So negative
1
degree Fahrenheit, yep.
Okay.
But then we're starting at?
Then we're going to add 4.
Yeah, because we started at 4 degrees.
Okay.
And then what do we do if we can't go kind of a rise over run or a fall over run? What kind of number do I put in to give myself that other amount to go left or right if we don't have that?
Okay, so would we have to know like what wait, so that's the temperature is going down.
So we just don't have a slope. So slopes are like rise over run, or change in y over change in x. That's our slope, or our m. So what do I need to put under that 1 to not change it, that -1 to not change it?
Oh, to turn it 1.
Yeah.
Yes.
So just now we can do, okay, now we have our slope, and now we have our y-intercept, so we can graph that.
Okay.
So yeah, we can go ahead and graph it.
All right.
We can start by graphing it. I think we can do it this way.
Okay, sounds good.
Okay, so go ahead and we're going to start at 4.
Starting at 4. So here's 0 right there, and I go 1, 2, 3, 4, or down.
Yeah, 4.
1, 2, 3.
Because it's starting at 4 degrees.
So I put my little dot.
Yes.
Okay.
It's very cold, but it's going down even more, which is happening in the winter.
Okay.
So now we're going to go down 1 to the right 1.
Down 1 to the right 1. Okay.
And just do that a few times.
Down 1 to the right.
Yeah, but we actually can keep going, because actually it can go into negative degrees Fahrenheit, so it doesn't actually matter. Yeah, and then we'll connect it.
Okay. Oh, I do.
A ruler.
Let me do that. Should I do the same color?
Yeah, that's fine.
Okay.
It's fine.
All righty. Here goes. Like you were saying, when students going into the classroom forgot things like how you hold the ruler.
Yeah, that's what I graph for like a tree activity to make like straight lines to curves, and you just practice holding the ruler, And I did that before I didn't even did like a graphing unit, because yeah, when you go to hold it, it like slips and
yeah,
stuff.
right, exactly. It's
and then
tricky.
We
And
could put, I think we could put arrows. I mean, if it ended up going up in temperature or down in temperature the same rate.
Sure.
All right, and maybe we'll put a 4 there so we know that it's going
Four.
starting at 4. Okay. Now let's do our next equation. You want to read town 2?
Okay. Town 2's temperature was going down an average of 3 degrees Fahrenheit every 5 days and started at 2 degrees Fahrenheit.
Okay. So now.
Oh, so this would be 3/5 then?
Yeah,
maybe?
down.
Okay.
So it's going down
Negative
3 degrees every 5 days to get us started at
2
degrees.
2 degrees.
So now we'll try that one.
Okay, new color. And so now I'm going to start not at 4, but
at 2.
Starting at 2. Okay, so here's 2, and it started at 2 degrees Fahrenheit, and down 3 every 5 days. Okay, what do I do now?
So start at 2.
Starting at 2. I'm at 2, so I'm putting a dot. Sorry.
You can write 2 even.
Okay,
there.
I will do that. Okay.
Then we're going to go down 3.
1, 2, 3.
To
yes.
the right 5.
1, 2, 3,
Ooh, it crosses
4,
perfect.
5.
I did that on purpose.
Yay! Okay.
You could do another one just because.
Okay. 1, 2, 1, 2, 3.
Oh, 3.
Oopsie, sorry. 1, 2, 3. 1, 2, 3, 4, 5.
Yes.
Alrighty.
And then we'll draw a line through that.
Okay.
And then we already see where it's crossing. I made it be a lattice point, but the point of graphing is it's not always a lattice point, but when I'm teaching it, it's nice to show that.
Yes.
So you can actually see that it works with algebra. Check your answer.
And I can put arrow.
All right.
An arrow.
Okay.
Okay.
So let's label somewhere what our independent axis is, which is, so we're having temperature per every, did I say day?
An average of degree.
Days.
Days.
So independently,
days, right.
X, time is passing, which is days. So we'll just do a different color for labeling.
Okay.
So we'll put X here.
Okay.
And we'll put like, I mean, we don't have anywhere to write it, maybe like up here, number of days.
Sure.
For my X.
Yes.
And then for my Y, over here, I don't know, we have another color.
Degrees Fahrenheit?
Yeah.
Okay.
Y, I mean, maybe I'll put it by degrees Fahrenheit, and that'd be like temperature.
Okay. Right.
I mean, typically you don't go, you have it like in a quadrant, so we're not labeling it direct, but I just want to know what we're talking
Yes.
about. So my X value answer will be days, and then my degrees Fahrenheit, and then let's see what that point of intersection is.
Okay.
Well, you can use black, I guess.
So for this, do you want me
So
to?
the point of this point of intersection, what is it?
The point of intersection
To the
is
right.
to the right 5, and then down 1.
So just put parenthesis 5 comma 1,
Okay.
negative 1, right? 5
Yes.
comma. So what does that mean in real life in this situation?
That means every 5 days.
After 5 days.
After 5 days, we've gone down 1 degree. We've dropped.
Well, that's where they cross.
Oh, they cross.
So like one is going, actually, I know what we can do is label the equation.
Okay, good.
So this one's going, whoops, that's not as a good green. That's what you do.
Yeah.
Down 1 degree, starting at 4. That's what that town 1 is. Here, town 1. Helps to like label it so it's easier to understand. And then town 2 is going down 3 degrees every 5 days and starting at 2. And then they are going to, as this is happening, they're both decreasing.
Yes.
They, after the 5 days, are going to both be at negative 1 degree Fahrenheit.
Oh, okay.
So that's basically, and a lot of times what I'll do is because with slope, we do rise over run, which is change in y over change in x. But when we're graphing or anything else, it's always alphabetical. But then I'll sometimes write like after 5 days, they're both at negative 1 degree Fahrenheit. So when it's a word problem, the other ones I'm going to do, they're just algebra. But it's nice to do a word problem so you're like, well, what does 5 negative 1 mean? It means after 5 days, they'll both be at negative 1
That's
degree.
really helpful. It's like these are units then to tell you what the numbers are.
But like town 1 obviously is going to now get colder faster, and town 2 because it's a negative 1 versus negative like 0.6 or negative 0.6.
Right.
And that then it will change. But yeah, that's where they cross. So
neat.
Pretty cool. Now what I'm going to do on the behind me is to solve it by substitution so you can see, okay, do we actually get 5 negative 1 if we solve it graphically?
All right.
Or like by algebra.
Sounds great.
So
would you like me to read for you?
Oh no, we're going to literally do the.
Oh, we're doing what we just did.
What we just did. So
I got it.
We're not. Okay, there we go. Y equals negative x, is it plus 4, I think?
Yes, it is, plus 4.
And then we have y equals negative 3 fifths x
plus 2.
Plus 2. So there's a method called substitution, and that's what we're going to do here. But there's a subset of substitution where you can just set them equal, because logically we want to know, where do these two towns equal each other? At what point is their temperature going to equal each other? Where are they going to cross? So like a little subset is you can just set them equal, but you're still doing substitution, and I'll show that. But basically what you can do, a subset of that, which is logical, is to like, okay, if y equals this, then I can plug this into this y. That's why it's substitution.
Oh.
But logically, if they both equal y, they both equal each other. So that's kind of like it's substitution, but it's like a kind of an easy logical way of substitution. Like, oh, when do they equal? Set them equal. They both equal y. So then we're just going to do some algebra to solve it.
Okay.
And again, if it wasn't a corner lattice point, this would be a better method. Like if it all of a sudden that was between, and we're like, where is that crossing? You'd want to just go to this method.
Okay.
So I'm going to do something, a CPM method called fraction busters, because when I see a fraction, I don't want to deal with it, and I don't have to. So I'm going to take that, divide by 5, and I'm going to multiply it by everything, and it will bust up, which is called fraction busters, and then I won't have any fractions. So then I'll have negative 5x plus 20. The 5's cancel. Negative 3x plus 10, and now I have a little bit bigger numbers, but I don't have any fractions, so I don't have to go, well, do I have a common denominator? And sometimes people you're doing this algebra problem, but you just get tripped up on the fractions. Sometimes if you can make it a little easier, you might make less mistakes just within it. And then you can tell me what to do.
Okay,
to
sounds
both
good.
sides.
So doesn't matter which side I start with? Okay, great. So what if I added 5x to both sides?
Sounds great. I usually have students get rid of the variables first, or get them together, so that you kind of get that out of the way too.
Yes, yes.
Just if you want a system, it doesn't matter. But yeah, because now when we do this, we end up with, now we just have, it's like almost like a normal two-step solving equations.
Yes.
And then what next?
Oh, next. Next I want to solve for x, so I subtract 20 from both sides.
And each time what we're doing, just a quick background, this isn't a solving equations lesson, but you're always going to do what's called the inverse operation, which will remove and give you the identity, and we have to do it to both sides because that's the property of equality. And you're always wanting to do the inverse to get the identity and balance it. But again, this is not that lesson, but I want to say what we're doing.
Okay, sounds good.
And then negative 20 plus 10 is negative 10.
And so now we divide both sides by 2, because that's what the x, and we want to see what the x is. Get rid of the 2.
And x equals?
X equals negative 10 divided by 2 is negative 5. Or 5. Negative 5.
No, it should be 5, because that's what we got. We did something wrong.
Okay.
I did something wrong, probably.
Would it be?
That's 10. Wait, did I write something wrong?
No. Oh, you mean like initially?
This happens.
Yeah, 3/5 plus x plus 2. You did not make a mistake there. Wait a second.
Negative 5x.
Okay, so we added 5x, and then we added 5x here. Wait, that's 2x? Yeah, 2x. But did you put the 2x? You put it on the wrong side.
Oh, that's why.
Yes.
Oh, yay.
You know, I'm so glad, because at some point I was not understanding. Now I understand why. Okay, awesome. I thought, well, Amy just moved it over there because what the heck?
We do this. I do this a lot, but they actually say a teaching method is to make mistakes so you can catch it. But I just naturally.
I would do that. Yes, frequently.
All right, here we go. 20.
All right, yay.
Yay
for that, yay.
Yeah, if something in math doesn't make sense, you don't just go, okay, I'm done.
Yeah, I don't get it. Just keep.
You keep persevering.
Yes, persevering and trying to figure out what the heck.
Math practice number 1 is to persevere in solving the problem.
Yes.
Okay, now we have 10 equals 2x.
Oh my gosh.
Now we divide by 2, and x equals 5, which is x is my independent variable, which is 5 days.
Yes, yes.
And because we're finding the point of intersection like we did under the mirror, we can plug it into either equation. Which is the easier equation to plug it into?
The easier equation would be the first one. We're town 1.
Yes, town 1. Negative x plus 4, but x is actually
5.
5, so negative, is it blue?
Negative,
5 plus 4, so what is the answer? Y equals?
Negative 1.
And y is our
that's
dependent,
perfect.
which is degrees
That's where we,
Fahrenheit.
Yes.
So now our xy is still 5, -1, and that confirms with our graphing.
Very
so that's
nice.
what's fun if you do both, because you can actually be like, it works.
That's really
So
cool.
if we go back to the mirror, you'll see that we do have 5, -1, and it does actually match the problem that I
matches
did.
with this.
And then we can
That's
move
so
on to
cool.
the next one.
So if you, I mean, you're more comfortable looking at this, then great. If you have difficulty graphing,
Yeah,
well,
and also on this,
practice.
if we see it's a lattice point where they cross versus if, like I said, lattice points are just corners when we graph. So if it didn't cross to the corner, like if we crossed in here, like all of a sudden it's like here and we don't even know what that is. Algebraically, we'll get that fraction or decimal exact. But if it crosses at a lattice point, it's pretty fun to actually, and I like to do it graphically because we can see that that's a point of intersection. When you just do things by algebra or you don't use real life, no one even knows what that answer means. Like we don't even know that that means like a point of, if I just did this, 5, oh, well, that's just random. No, it's a point of intersection of two lines of two temperatures where they cross as one's going down, as one's going down. So anyway, yeah, I like to do both. So we are going to move on.
Okay.
And in case we don't have time, I'm going to switch to a method called elimination so that, and then we'll come back to a harder substitution one if we have
Okay.
time.
Oh, am I getting rid of the information here?
We are,
cleaning?
yes, we are
Okay,
cleaning.
good. I am cleaning.
So we're going to start by graphing, and we're going to use a method called elimination.
All right.
So what I'm going to do is put them into slope y-intercept form, and then I'm going to do the method of elimination on the board after we solve it graphically.
Nice.
So we need to put them in slope y-intercept form. So I'm going to start with the first one.
Okay.
4y minus 3x equals 12. And I made sure these actually work out beforehand.
So the first
So what do I
thing
do to
is
both sides?
You add 3x to both sides?
Yeah, because what we're going to want to do
You want the y.
yeah, is y equals mx plus b. Yep. So we have 4y equals
Equals 12 plus 3x.
So I'm going to put the 3x first just so it's
plus
yeah, I'm just
12.
yeah, you can
Is
do it
that
either
right?
way,
Okay,
but yeah.
sounds good.
And then what do I do?
Then you're going to solve for the y, so you're going to divide both sides by 4.
And then what do I have to do on this side though? I have to make sure I
Oh, that's, yes.
distribute
you're
it
gonna
to
do them
both. Yep.
That's right.
So it's to everything. So y equals
Y equals 3 or 0.75. No, 3/4 x.
yeah, because we want to rise over run, so we want a fraction.
I got you. Plus 12 over 4, which is 3.
Yep. So there's our one equation, and we're going to graph. And I made it so that worked on lattice points. I picked the ones that work.
Yay!
And then we'll do the next one, which actually is going to be much easier because look, we only have to do
Right.
What do I do to both?
Just
whoops.
subtract
Equals
2x.
negative.
Subtract 2x.
Subtract 2x from both sides, so then my
Yes.
equation is?
The equation is y equals negative 2x plus 8.
It's actually a minus 8.
Oh, minus
I just
8,
accidentally
minus 8, okay.
wrote the equal sign.
Got it.
There
There
we
we
go.
go.
So we are going to graph these two equations right here.
Neat.
Right
Here I
now.
go. Here I go with your assistance. All right,
Yes.
so 3, 4.
So we're going to start though our y-intercept.
With 3.
Yes, and I'll just write y equals
So
mx
3.
plus b again.
1, 2, 3. So I go up 3, right? That's
Yep.
where I start. Okay.
M is slope, which is change in y over change in x, and b is our y-intercept.
3 down and then 4 over.
Well, it's rise over run, so we're going to lift our foot like a stair. So we're going to go up 3 to
up
the
3.
right 4.
Got it.
Up
1,
3
2, 3.
to
and
the
then
right.
1, 2, 3, 4. Got
Yep.
it. Okay. 1, 2, 3. 1, 2, 3, 4. There we go.
And we can also go the reverse.
Oh.
If you're going positive, positive, you can go
1,
negative,
2,
negative.
3, 1, 2, 3,
Yeah, because the negative
4.
divided by negative is also a positive.
Sweet. 1, 2, 3. 1, 2, 3, 4.
Perfect. All right,
Yay,
we're going to put a line
connect.
through it. Yes.
Oh, this is good.
It's exciting. I just love doing them when you do the graphing and the algebra, and they match. It's just so exciting.
It is exciting.
It's rewarding.
Very rewarding. It's very helpful. It's helpful to know
we'll
that
put
both
arrows.
ways work. Okay.
And then maybe we'll label it later.
Shut up.
Sometimes I
All
label
right.
it afterwards because
Okay.
otherwise it crashes into the other one. And
Okay.
you're putting the line
Let's
through.
get it too messy. We don't
Yeah.
want too messy. All right.
And then where does this one start?
This one starts at the under 8 over
Yeah,
here, down
yes.
here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I
Yes.
start here and then I
Yes.
go to.
You actually are going to go down for this one. You're going to go down 2 to the right one. Is that at negative 8?
This is negative. Where
Yeah,
am I?
go ahead.
Right
Yeah,
here.
go ahead.
Okay,
Put
go
that
down 1, 2.
to the right 1.
Oh, oopsie. To the right 1 and then 1.
No, down 2.
Sorry, down 2, 1,
So-
2, and right 1.
So I call
Got it,
this
got it,
one,
got it,
like
got
for
it.
3 over 4, I do rise over run.
Okay.
And I actually say for this one, it's fall over run because you're actually going down.
Okay.
But the inverse, if you're going negative over positive, is you can do positive,
2.
negative. And then go
And then
back.
1.
Yep.
Okay.
Because it's the same thing.
1, 2,
Because a 2
1.
divided by negative 1 is the
1, 2,
same as a negative
1.
2 divided by positive 1.
1, 2, looky.
Yay!
1, 2, 1. 1, 2, 1. Okay, well, I think we're good for making a line.
And we do have the point of intersection, so that's exciting.
Yes. That's happy. Nice. You know, we use this sort of thing in science all the time as well. Graphing data is really important.
And then we can
label.
then we can label it now. We can write like
All right.
along here y equals negative 2x minus 8. Or I just write it along the line like it's a line.
Oh, okay, got it.
Y equals
negative
2x minus 8.
X minus 8, and then
This one
X
we'll do
equals
y equals, and I just put
My
it like
X
up
equals,
here,
right?
up there. Yeah. Because then we can do the point of
What
intersection.
was X
It's
equal?
y equals.
Oh my
gosh.
gosh and gosh. Okay,
It's
got it.
y
of
equals
course it is.
3/4 x.
3/4 X plus, or subtract.
It's plus 3.
Oh, good.
I know this is kind of a pet peeve.
No,
but I put
do
the
not
3 over.
slash 3 on top.
Yeah, because otherwise students, it looks like the x is on the bottom, like it's almost like exponential or something like that. Or
3/4
inverse, I mean.
Plus 3.
3/4 x.
X, sorry.
Yep,
plus 3.
Yeah, I just do that because otherwise the x ends up looking like it's in the denominator sometimes, and then that'd be inverse.
All right.
All right, now we need the point of intersection, so we'll do that.
All right. Point of
Do it with a different color.
intersection, different color.
So where do they cross? X, y is left 4 up 0, it looks like.
Left 4,
So parenthesis, negative 4, 0.
comma 0.
Yeah, and I do parenthesis x, y, so students know that it's actually x, y. So same thing, but just with x and y. Parenthesis x, y.
Okay. Gosh, I got it now.
Yeah,
so
just,
they're
because
sure
otherwise
they
we're
know.
doing rise over run, which is y over x. Now we're plotting, which is x, y, and then people just mix it up, which it's always alphabetical unless you're doing rate.
Okay.
Slope. So now we're just going to solve it by elimination on the whiteboard, and we should get negative 4, 0, hopefully.
Good.
So I'm going to use the original equations because it's an elimination
Okay, the
problem.
original equation was 4y
I think I'm good. Okay, 4y.
minus 3x equals 12.
Okay.
And the other equation is, are we solving now?
No, I need the other one.
Okay, the other one. Sorry, y plus 2x equals negative 8.
So before we had a thing where we had y equals, so we'd substitute, but here they're above each other. That's not going to be, I could minus 2x and do that, but there's a way called elimination where you eliminate the variables.
Okay.
Now we can do a lot of things. We can make it so that this is negative 6 and positive 6, but this is already a positive 4, so I could just multiply that by negative 4 and I won't have to, but there's literally lots of ways to do this.
Okay.
But I like to go with the least resistance, which is like multiply this whole thing by negative 4. Then I only have to change one equation instead of both, but I have to make sure I distribute it to everything.
Okay.
But now the top one stays the same.
Yes.
But the bottom one, I know,
Becomes
negative 4y.
Negative 4y plus 8x, or negative minus 8x equals 32?
Yep, opposite of a negative is a positive. But now look, yay, this is where it's exciting. You get to eliminate y at 0, the identity.
Oh
so
my
now
gosh, yeah.
I just have negative 8x and negative
You
3x's.
get to add those, so it's negative 11.
Yeah, because they're the same
X.
sign, so we're combining like terms.
Okay, plus
And then
44
32 equals 44.
equals 44.
Yep. And then what do we do to both sides?
Divide by 11.
Negative 11, but yeah.
Oh, you're negative 11.
And then x equals?
Whatever. Oh, 4. Does it?
Opposite of a positive is a negative, so negative 4,
okay.
yeah. And our point over there on the graph was negative 4 comma 0.
Yes.
So now we're going to plug it. Which one do you want to plug it back into? We have the black up here and here, the first or second one?
The first one.
I'd probably do the second one because it's way less stuff. Well, see, I always try to pick the least resistance, and that's like a plus 2x barely.
And I think I was confused because I saw all these things moving around there. So yeah, go ahead.
Oh, yeah.
Do the second one. It's fine.
You can do either, just in terms of, I try to do the least amount of work since it's part of both.
It makes sense.
But then my x, instead of x, is going to be what? What do we just solve for x?
Yeah.
So what do we solve for x?
Oh, wait, what do we solve for? I'm sorry. Oh, it's negative 4.
Yes.
Okay.
So then we have y, 2 times negative 4 is
negative 8.
So I put an equal sign, so just get rid of that real quick. And then we'll go back to black.
Okay.
minus 8, is that what we
Minus
said?
8, yes.
Equals minus 8, so what do we do to both sides?
Divide both sides by 8.
Add both
or
sides.
add both sides
Yeah.
by 8,
No, it's
yes.
totally fine. And y equals?
Y equals
Negative 8 plus
negative
8
plus
is?
8 is positive 16. No, negative 16. Oh,
0.
adding 0.
It's fine. It doesn't matter.
Oh, that's
it's
good.
all good. It's all good.
It's good.
So my answer is xy, which is negative 4, 0. But that literally was what we just did on the paper.
Yes,
so
yes.
it confirms that we
It
are
works.
correct algebraically.
Very nice.
That it matches. And elimination is a cool, actually I'm going to write elimination. I didn't write that.
Okay.
So one way is substitution. We circled and substituted, which is this last page. I'll just go do this real fast.
Okay.
So substitution, we're not going to do another one, but it's where you set it equal, but I'm literally, y is called this, and I can plug it in. That's called substitution. And then the other way is called elimination, and that's where you make it so that you can eliminate a variable. And that's important if they're kind of lined up, so you don't have to do extra. You kind of want to do it where you don't have extra steps. Are they stacked up in standard form? Do you want to eliminate? Or does it say y equals, or x equals, or a equals? And then you can circle, and it's renamed, and you can plug it into that, and that's substitution. And obviously the third way is graphing. And then we can go ahead and look and see that it matches on the graph. Yep, there we go.
And it
Negative
matches.
4, 0.
Negative 4, 0.
So you can put it in slope y intercept form and graph it, or you can set it up to where you eliminate a variable. But yeah, so basically the 3 ways are graphing.
Yes.
Oh, yeah, y'all ask you, what are the 3 ways of solving
Okay, thank
systems
you.
of equations?
They are graphing
Yeah.
and substitution and elimination.
Yeah, so those are 3
Cool.
different ways. And the only, like, graphing is going to be great unless you don't have those lattice points, and then you're going to want to, and honestly, if you're graphing and you're like, is that right? You could always try it algebraically, and then that's what's nice with math and science is you can kind of do multiple ways to kind of confirm your data, and then it matches, and then you can.
And I like the way we started, that we're actually using like the towns and the actual data. So we use data to solve, because then it always makes the numbers more real. When you have it, you can apply it to something.
Yes, so that was the substitution
Who
one.
doesn't? Temperature is perfect.
Substitution.
I got a gift, I gave myself something. I ordered something today, and it came with a bunch of dry ice. I thought, so much, should I bring it? But it was just giant hunk of it. Speaking of temperature, I thought that was kind of cool.
Because doesn't it cool?
It does. It will sublimate. It will turn directly into a gas.
Yeah, we did a problem because we do real life data and integrated one, but we do it with like a linear regression in terms of like lattice points and stuff like, or not in terms of data points, stat plot, statistical plot. But we did it linearly, and we did a residual plot, and it was curvy. And then they haven't studied exponential, but I did it was about dry ice, and then I did it exponentially, and the correlation coefficient was like way closer, and the residual plot was way random, and so it was really cool about the dry ice. Is yes, with graphing you can check things when you get into integrated one, but I'm just saying I just did that in class, and it was so cool to be like, oh, is this a linear regression or is this an exponential regression? And with the dry ice example, it actually was an exponential regression.
Oh my gosh, that's so neat.
But anyway, we did linear today.
Yay
Anyway,
for math!
thank you
Yay
so
for
much.
math! We really appreciate it. Thanks, guys, for showing up.
Thank you.
Thank you.